Introduction to AWS IAM PassRole. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Today we are diving into one of the most critical, yet often misunderstood, concepts in AWS identity and access management, which is the PassRole permission. Understanding PassRole is essential for anyone working with AWS services because it governs how roles are delegated to AWS services on your behalf. This concept sits at the intersection of security and functionality, and getting it wrong can either create security vulnerabilities or prevent your applications from working correctly. PassRole is fundamentally about delegation. When you create resources in AWS like EC2 instances, Lambda functions, or ECS tasks, these services often need to perform actions on other AWS services. For example, an EC2 instance might need to read from an S3 bucket, or a Lambda function might need to write to a DynamoDB table. Instead of embedding credentials directly into these services, which would be a security nightmare, AWS uses IAM roles. The service assumes the role and uses its permissions to perform actions. However, there is a security challenge here. If any user could assign any role to any service, they could effectively escalate their privileges. Imagine a scenario where you have limited permissions, but you can create an EC2 instance and assign it a role with administrator access. You could then use that EC2 instance to perform privileged actions you should not have access to. This is where the PassRole permission comes into play. It acts as a gatekeeper, controlling who can assign which roles to which AWS services. Looking at the diagram on the slide, we can see the complete authorization flow. At the top, we have a user or service attempting to create a resource. The first checkpoint asks whether this entity has resource creation permission. If not, the request is immediately denied with an access denied error. If this check passes, we move to the second checkpoint, which asks whether the entity has PassRole permission for the specific role being assigned. Without this permission, we get a PassRole error. The third and final checkpoint evaluates the role's trust policy to determine if the AWS service is allowed to assume this role. If the trust policy does not permit the service, we get a trust policy error. Only when all three checkpoints are satisfied does the flow proceed to successfully create the resource with the role assigned. This multi-layered approach ensures security from multiple angles. What is PassRole? Let's start by defining exactly what the PassRole permission is and why it exists in the AWS security model. PassRole is an IAM permission that controls whether a user or service can assign an IAM role to an AWS service. The action is denoted as IAM:PassRole in IAM policy documents. This permission is required whenever you want to associate an IAM role with an AWS resource that will assume that role to perform actions. The key word here is assign or pass. You are not assuming the role yourself. Instead, you are giving permission to an AWS service to assume that role. This is a crucial distinction. When you assume a role directly using sts::assume role, you are taking on the permissions of that role yourself. With PassRole, you are authorizing a service like EC2, Lambda, or ECS to assume the role and act with its permissions. This delegation mechanism is what makes PassRole unique and security sensitive. Now let's examine the sequence diagram on the slide, which illustrates the complete PassRole flow. At the top left, we have the user who initiates the process by sending a request to create a resource with a role. This request goes to the AWS service, shown in the middle of the diagram. The AWS service then communicates with IAM to check the PassRole permission. IAM evaluates whether the user has the necessary IAM:PassRole action for the specified role and responds with permission granted back to the AWS service. Next, the AWS service communicates with the IAM role itself to check the trust policy. The role evaluates its trust policy to determine if this particular service is allowed to assume it, and responds with service allowed back to the AWS service. With both checks passed, the AWS service now performs the actual role assumption using the assume role operation. The IAM role responds by providing temporary credentials back to the AWS service. Finally, the AWS service sends confirmation back to the user indicating that the resource was created successfully. This sequential flow shows how pass role and trust policies work together to authorize role delegation. The pass role permission flow. Understanding how pass role works requires examining the complete flow from user action to service assumption. Let's walk through this process step by step to see where pass role fits into the larger picture and how all the pieces work together to maintain security while enabling functionality. The flowchart on the slide provides a detailed visualization of this authorization process. Starting from the top, we see the start node representing when a user creates a resource. The flow immediately moves to the first authorization check labeled Check Resource Permission. This is where AWS evaluates whether the user has permission to create the resource itself, such as EC2 run instances for EC2 instances or Lambda create function for Lambda functions. If this check fails, the flow follows the fail path to an error 1 node labeled Access Denied, and the entire operation terminates. If the check passes, the flow continues to the second authorization check labeled Check Pass Role Permission. At the pass role check, AWS evaluates whether the user's IAM policies include the IAM:pass role action for the specific role being assigned. The pass role permission can be scoped to specific roles using resource ARNs in the policy, or it can be granted more broadly with wildcards. If this check fails, the flow follows the fail path to error 2 node labeled Pass Role Error, and the operation terminates with an error message indicating the user is not authorized to pass the role. If the pass role check succeeds, the flow moves to the third authorization check labeled Check Trust Policy. The trust policy check evaluates the role's assume role policy to determine if the AWS service is listed as a trusted principal. For example, a Lambda execution role must have lambda.amazonaws.com in its trust policy. If the trust policy does not permit the service to assume the role, the flow follows the fail path to error 3 node labeled Trust Policy Error. Only when this third check passes does the flow continue forward. The successful path proceeds to the Create Resource node where the AWS resource is actually created, then to Attach Role to Resource where the role association is established, then to Service Assumes Role where the AWS service performs the assume role operation, and finally to Access node labeled Service Has Role Permissions where the service can now use the role's permissions to perform actions. This flowchart makes it clear that pass role is just one of 3 critical security gates, and all 3 must be satisfied for role delegation to work properly. The multi-layered approach ensures that role delegation is authorized from multiple angles. Common use cases for pass role. Pass role is required in numerous AWS scenarios where services need to perform actions on your behalf. Understanding these common use cases helps you recognize when and why you need pass role permissions in your IAM policies. Let's explore the most frequent situations where pass role comes into play and what each scenario looks like in practice. The mind map diagram on the slide organizes pass role use cases into logical categories. At the center is the root node labeled pass role use cases, which branches into 3 main categories: compute services, data services, and automation. Let's walk through each branch to understand the structure. The compute services branch contains 3 sub-branches. The first is EC2 instances, which further branches into instance profiles and application access. When you launch an EC2 instance with an instance profile, you need both EC2:run instances permission and IAM:/pass role permission for the role contained in that instance profile. The second sub-branch under compute services is Lambda functions, which branches into execution roles and service integration. Every Lambda function requires an execution role, and creating or updating a Lambda function with a role requires pass role permission. The third sub-branch is ECS tasks, which branches into task execution role and task role. ECS tasks can have two types of roles, and you need pass role permission for whichever roles you assign to the task. The Data Services branch contains two sub-branches. The first is Glue Jobs, which branches into data access and transform operations. AWS Glue Jobs need roles to access data sources and perform transformation operations. The second sub-branch is Data Pipeline, which branches into pipeline activities. Data Pipeline uses roles for its various pipeline activities to access resources. The Automation branch contains two sub-branches. The first is Step Functions, which branches into state machine execution. Step functions state machines need roles to invoke Lambda functions and other AWS services. The second sub-branch is Code Build, which branches into build operations. Code build projects need roles to access source code repositories and artifact storage locations. Below the mind map, the table provides concrete examples showing the relationship between services, role types, and required permissions. The first row shows that for EC2, you need an instance profile role type, and the required permissions are EC2:run instances plus IAM PassRole. The second row shows Lambda requires an execution role, and you need Lambda create function plus IAM PassRole. The third row shows ECS needs a task role, and you need ECS registered task definition plus IAM PassRole. This pattern is consistent across all AWS services that support role delegation. Pass role syntax and structure. Let's examine the exact syntax and structure of pass role permissions in IAM policies. Understanding how to write pass role statements correctly is essential for both granting appropriate access and avoiding security vulnerabilities. The pass role permission follows the standard IAM policy structure but has some specific characteristics that are important to understand. A pass role permission statement in an IAM policy includes several key components. The effect field specifies whether you are allowing or denying the action, and this should be set to allow in most cases. The action field specifies the permission itself, which is IAM pass role. The resource field is particularly important because it specifies which roles can be passed. This is where you define the scope of the pass role permission. You can specify individual role ARNs, use wildcards for pattern matching, or grant broad pass role permissions across all roles. Looking at the first code example on the slide, we see a pass role policy for a specific role. The policy has version set to 2012.10.17, which is the current policy language version. Inside the statement array, we have a single statement with effect set to allow, action set to IAM pass role, and resource set to ARN AWS IAM beginning with 12 and ending with 12 role/my Lambda role. This grants pass role permission for exactly one role. The ARN format is ARN AWS IAM followed by the account ID beginning with 12 and ending with 12, then role/, and finally the role name my Lambda role. This is the most restrictive and secure way to grant pass role permission because it limits the permission to a single, explicitly named role. The second code example shows a pass role policy with a wildcard for a role family. The structure is similar, but the resource field is now ARN AWS IAM 1234567891012 role/lambda-**, where the asterisk is a wildcard that matches any role whose name starts with lambda-. This would match roles named lambda-dev, lambda-prod, lambda-test, and so on. Using wildcards like this allows you to grant pass role permission for multiple related roles without having to list each one individually. This is useful when you have naming conventions for roles and want to grant permissions based on those naming patterns. The third code example demonstrates a pass role policy with a service restriction condition. In addition to the standard effect, action, and resource fields, this statement includes a condition block. The condition uses string equals to compare IAM passed to service with ec2.amazonaws.com. This means that even though the user has pass role permission for my app role, they can only pass this role to the EC2 service. If they try to pass the same role to Lambda or any other service, the condition check will fail and the pass role operation will be denied. The IAM passed to service condition key is one of the most important security features for pass role because it provides an additional layer of control beyond just specifying which roles can be passed. Scoping pass role with conditions. Conditions in pass role statements provide powerful ways to implement fine-grained access control over role delegation. By adding conditions to your pass role permissions, you can restrict not just which roles can be passed, but also to which services, under what circumstances, and by whom. This granular control is essential for implementing security best practices and maintaining the principle of least privilege. Looking at the first code example on the slide, we see how to restrict pass role to a specific service. The policy statement includes action set to IAM pass role, and resource set to ARN:AWS:IAM:**role/lambda execution **, which uses a wildcard to match any role starting with lambda execution *. The critical part is the condition block, which uses string equals to compare IAM: passed to service with lambda.amazon.aws.com. The IAM: passed to service condition key is evaluated when the pass role operation is performed, and it restricts which AWS service the role can be passed to. In this example, even if you have pass role permission for a role like lambda execution-dev, you can only assign it to Lambda functions. If you try to attach the same role to an EC2 instance, the condition will fail and AWS will deny the pass role operation. The service principal format is important here. You must use the correct service principal such as lambda.amazon.aws.com for Lambda, ec2.amazon.aws.com for ec2, or ecs-tasks.amazon.aws.com for ecs tasks. The second code example shows how to restrict pass role to specific regions. The resource field uses ARN::AWS:/IAM::role/production-* to match roles starting with production-. The condition block uses string equals with AWS: requested region to specify an array of allowed regions, in this case S East 1 and S West 2. When a user attempts to pass a production role in a region, AWS evaluates this condition by checking the region where the API call is being made. If the user tries to pass a production role in EU West 1, the condition fails because EU West 1 is not in the list of allowed regions. This is valuable for organizations with regional compliance requirements or those implementing multi-region architectures with different security boundaries. You might allow passing certain roles only in your primary production regions while preventing their use in development or test regions. The third code example demonstrates restricting pass role based on role tags. The resource field uses an asterisk wildcard to match all roles, which seems permissive, but the condition block provides the restriction. It uses string equals with AWS::resource tag/environment to compare against the value development. This condition checks the tags attached to the IAM role itself. If you tag your IAM roles with an environment tag, you can write pass role policies that reference these tags. In this example, a user can pass any role, but only if that role is tagged with environment equals development. If the role is tagged with environment equals production, the condition fails and pass role is denied. This approach is flexible because it scales automatically as new roles are created and tagged appropriately. You don't need to update the pass role policy every time a new development role is created. As long as the new role is tagged correctly, the condition will allow it. The highlight box emphasizes the best practice of always using the IAM passed to service condition to prevent role misuse across services. This is one of the most important security controls for pass role because it ensures that roles are only used in their intended service context. Pass role and trust relationships. The relationship between pass role permissions and IAM role trust policies is fundamental to understanding how role delegation actually works in AWS. These two mechanisms work together to create a complete authorization model, and understanding their interaction is crucial for both proper configuration and troubleshooting access issues. Let's explore how these pieces fit together and what happens when they are not properly aligned. Looking at the flowchart diagram on the slide, we can see how pass role and trust policies interact in the delegation process. On the left side, we have user with pass role who represents a user or principal that has been granted the IAM:pass role permission. This user assigns a role to an AWS resource, shown as a box in the middle. The resource then attempts to assume the IAM role, represented by a box on the right side. The role evaluates its trust policy, and if the trust policy allows the service, the flow continues to STS assume role where the security token service processes the assumption request. STS returns temporary credentials, represented by the creds box, which flow back to the resource. These credentials are then used by the resource to perform operations. Below the main flow, we see two dotted lines representing the control relationships. The pass role permission box connects with a dotted line to the user, indicating that pass role controls the assignment action. The trust P box, representing the trust policy, connects with a dotted line to the trust node, indicating that the trust policy controls the assumption action. This diagram clearly shows that pass role and trust policies are separate but complementary controls. Now let's examine the two code examples that show trust policy structures. The first example is a trust policy for Lambda. The policy has version set to 2012-10-17 and contains a statement array with a single statement. The effect is allow. The principal is set to service with value lambda.amazonaws.com, and the action is sts::assume role. This trust policy explicitly allows the Lambda service to assume this role. When you create a Lambda function and pass this role to it, Lambda will be able to successfully assume the role because the trust policy permits it. The service principal lambda.amazonaws.com is the key identifier that AWS uses to verify that the Lambda service is making the assume role request. The second code example shows a trust policy with an additional condition. The structure is similar with effect set to allow, principal set to service with value ec2.amazonaws.com, and action set to sts::assume role. However, this statement includes a condition block using string equals to compare AWS::source VPC with VPC 1234556. This means that even though the EC2 service is allowed to assume the role according to the principal field, the assumption will only succeed if the EC2 instance is running in VPC 1234556. If an EC2 instance in a different VPC tries to assume this role, the trust policy condition will fail and STS will deny the assume role request. This shows that trust policies can include their own conditions that are evaluated independently from pass role permissions. You might have pass role permission and successfully attach the role to an EC2 instance, but the instance will fail to assume the role at runtime if it doesn't meet the trust policy conditions. Security implications of pass role. Understanding the security implications of pass role is critical for maintaining a secure AWS environment. Pass role is one of those permissions that seems simple on the surface but has profound security consequences when misconfigured. Let's examine the specific security risks associated with pass role and how to mitigate them through proper policy design and governance. The primary security concern with pass role is privilege escalation. The sequence diagram on the slide illustrates a privilege escalation attack scenario. At the top left, we have an attacker who is actually a limited user with restricted permissions. The note above the attacker indicates they have EC2:run instances permission and broad pass role permission. The attacker launches an EC2 instance with an admin role, shown by the arrow from attacker to EC2 instance. The EC2 instance then assumes the admin role, shown by the arrow from EC2 to role. The role returns admin credentials back to the EC2 instance. The attacker then connects to the instance, shown by the arrow from attacker back to EC2. Now using the admin credentials, the EC2 instance sends a request to delete a bucket to the S3 service. S3 responds with success because the admin credentials have the necessary permissions. The note at the bottom indicates that privilege escalation has been achieved. This sequence shows how a user with limited direct permissions can effectively gain administrative access by creating a compute resource with a highly privileged role and then using that resource to perform privileged operations. Below the sequence diagram, we have a table that summarizes different security risks with PassRole. The table has 3 columns: risk, scenario, and mitigation. The first row shows the privilege escalation risk, where the scenario is a user passing an admin role to EC2 or Lambda, and the mitigation is to scope PassRole to specific role families. This means instead of granting PassRole for all roles, you grant it only for roles that follow a specific naming pattern like application-star or lambda-dev-star. The second row shows lateral movement as the risk, where the scenario is accessing other teams' resources via their roles, and the mitigation is to use the IAM passed to service condition. This prevents users from using roles in unintended service contexts. The third row shows compliance violation as the risk, where the scenario is uncontrolled access to sensitive data, and the mitigation is regular PassRole permission audits. Organizations should periodically review who has PassRole permissions and for which roles to ensure the permissions remain appropriate. The warning box at the bottom emphasizes that broad PassRole permission combined with compute service access enables privilege escalation attacks. This is a critical security principle to remember when designing IAM policies. PassRole in AWS Organizations. When working with AWS Organizations, PassRole takes on additional complexity because you are managing role delegation across multiple accounts. Understanding how PassRole interacts with organizational structures, service control policies, and cross-account access patterns is essential for implementing secure and functional multi-account architectures. The graph diagram on the slide illustrates the organizational structure and how PassRole works within it. At the top, we have the AWS Organization node, which represents the entire organization. This branches into 2 main nodes: the management account and an organizational unit labeled OU1. The management account is the root account of the organization. The organizational unit branches further into 2 member accounts: Member Account 1, labeled ACCT1, and Member Account 2, labeled ACCT2. On the left side, we see a Service Control Policy node labeled SCP. Dotted lines connect the SCP to the OU1 node with the label Restricts, showing that the SCP applies restrictions to the organizational unit. Additional dotted lines connect the SCP to both ACCT1 and ACCT2 with labels Denies PassRole for admin roles, indicating that the SCP prevents passing roles with admin in their names in these accounts. Within Account 1, we see a local IAM role node labeled Role1, and a user in Account 1 who needs PassRole permission to use Role1. Within Account 2, we see another local IAM role labeled Role2. A dotted line connects Role1 to Role2 with the label Can Assume, showing that the role in Account 1 has permission to assume the role in Account 2. This illustrates the cross-account pattern where PassRole controls local role assignment in each account, while assume role permissions on the roles themselves enable cross-account access. Below the diagram, we have 2 code examples. The first shows an SCP denying PassRole for privileged roles. The statement has effect set to deny, action set to IAM PassRole, and resource set to ARN AWS IAM *role/ admin *, which matches any role with admin in its name across any account. The condition block uses string not equals with AWS:principal org ID comparing against organization ID 0-1234567890. This SCP structure means that any attempt to pass a role with admin in its name will be denied unless the principal belongs to the specified organization. This is an organization-wide security guardrail that overrides any IAM policies in member accounts. Troubleshooting pass-role issues. Pass-role errors are among the most common access issues in AWS, yet they can be confusing to diagnose because they involve multiple authorization layers. Let's walk through the common pass-role error scenarios, how to identify what is wrong, and how to fix each type of issue. The flowchart on the slide provides a systematic troubleshooting approach. At the top, we have the pass-role error node, which branches into a decision diamond labeled error type. This diamond has three possible paths: not authorized, trust policy, and runtime. Let's follow each path. The not authorized path leads to a node labeled check IAM policies for pass-role action, which is fix 1. This tells us to verify that the user's IAM policies include the IAM:pass-role action. From fix 1, we reach another decision diamond labeled resource matches. If the answer is no, we proceed to update 1, which instructs us to update resource ARN in policy. This means the pass role permission exists but the resource ARN doesn't match the role we're trying to pass. If resource matches returns yes, we proceed to another decision diamond labeled condition satisfied. If the answer is no, we go to update 2, which tells us to adjust conditions or context. This means a condition in the pass role statement, like IAM:passed to service, is not being met. If condition satisfied returns yes, we proceed to check 3, which instructs us to review SCPs. This means IAM policies look correct, so the issue might be a service control policy denying pass role at the organizational level. Going back to the error type diamond, the trust policy path leads to fix 2 labeled update role trust policy with service principal. This indicates the pass role permission is working, but the role's trust policy doesn't allow the service to assume it. The solution is to add the appropriate service principal to the trust policy. The path continues to a trust node labeled add service principal to trust policy. The runtime path from error type leads to fix 3 labeled check role permissions not pass role issue. This indicates the role was successfully passed and assumed, but it lacks permissions to perform the intended actions. The path continues to a perm node labeled add required permissions to role policy. This is not actually a pass role problem but rather a permissions problem with the role itself. Below the flowchart, we have 3 code examples showing troubleshooting commands and common errors. The first example uses the AWS CloudTrail lookup events command. The lookup attributes parameter specifies attribute key equal operator event name and attribute value equal operator pass role to search for pass role events in CloudTrail. The max results parameter is set to 10 to limit the output. This command helps you find pass role attempts in your CloudTrail logs to see what was tried and whether it succeeded or failed. The second example uses AWS IAM simulate principal policy to test pass role permissions. The policy source ARN parameter specifies the ARN of the user you want to test. Action names is set to IAM:pass role, and resource ARN specifies the role ARN you want to test passing. This command simulates whether the user has pass role permission without actually attempting to pass the role. The third example shows a common error message. User is not authorized to perform IAM pass role on resource followed by a role ARN. This is the typical error when pass role permission is missing. The fix shown adds a policy statement with effect allow, action IAM pass role, and resource set to the specific role ARN. Thank you for your attendance. Please consider subscribing to the channel and liking this video.